So we'll go ahead and make a commit. And now as far as tests go, I like to keep my tests in a separate project. So we'll go ahead and minimize the existing projects that we have in our solution, and I'll go ahead and close all of the tabs. And now I'll right click on the solution and we're going to add a new project. And we can actually just make this a class library. That's going to be fine. And I'm going to call it lambda forums.tests. And we need to add some dependencies here to this project. So if we right click and we're going to manage NuGet packages, and then we're going to go ahead and browse. And the first package that we're going to install is called NUnit. And I've used a number of different testing frameworks for .NET, and I find NUnit both in terms of syntax and in general just the way things are set up. This is kind of my preferred framework, so it's the one that I'll recommend for this series. And we're going to make sure that we install version 3.8.1. And then in order to run our tests in Visual Studio, we're going to go ahead and install this NUnit 3 test adapter as well. The next thing that we need to make sure we have installed is the Microsoft .NET Test SDK. And so we'll go ahead and install this as well. There is another package that I like to use, and I won't go into any detail in this particular series, but it's called Fluent Assertions. And this is a really fantastic package as well. It makes the assert syntax quite a bit nicer, and it gives you some very useful feedback about why tests fail. But we're not going to go into it in this particular series. So, all right, we're going to go ahead and close out of NuGet. Okay, so one thing we need to do actually before we start writing tests is make sure that we add a reference to each of the other projects in our solution here. So ensure that you have checked your references for the lambda forums.test project, and go ahead and add references to the web layer, the data layer, and the service layer. Okay, so the way that we're going to use NUnit here is that we have a public class, and in fact let's go ahead and just rename this, and let's name it search service tests. And so we'll go ahead and name the class search service test. I've also seen convention where people write tests like search service should, and then they write methods, say like public void return results corresponding to query, or something like this, you know, some behavior of the test. And so we can write our test class like this if you like. It does sometimes kind of show the intent of the class, particularly if you see a giant list of test classes and you're trying to understand what each test is trying to cover. This is one way you might think about doing it, just by naming the classes like this. So in any case, the way that NUnit is going to work is we're going to add attributes to our classes and our methods to control the flow of our tests. So for classes, we're going to label classes that contain test methods as test fixtures. And so this is going to tell NUnit that everything in this class is a test that should be run. And then for the methods themselves, we're going to go ahead and give them the test attribute. And there are other attributes we'll look at in a little while here, for example, like running different test cases, like parameterizing your testing, which is definitely a really good idea. But we'll start out with a simple test. And so, yeah, our first test can be this. The search service should return results corresponding to query. So we're going to test our post service, actually. And you can see that our post service has these methods, get filtered post, and it has two overloads, one in which we just pass a search query and another in which we pass a specific forum and a search query. So let's test this, the broadest method here, the one that's going to return all posts from our database that contain our search query in either their title or their content. And so we'll call this post service, and we can say like return filtered results corresponding to query. And so the way we're going to set this up is we're actually going to use an in-memory database version of our DB context. So the way we can do that is by using something called DB Context Options Builder. So for this, we need to bring in Entity Framework Core and pass it our application DB context type. And now we can call dot use in-memory database and give it a database name. We'll just call this one our search database dot options. So now we have the options that we'd like to use whenever we implement our DB context. And so we'll structure our tests like this. First, we're actually going to arrange our test scenario, and then we're going to take some action, and then we're going to assert. So you'll hear this as a sort of paradigm in testing where you want to kind of set the stage and then perform some action and then assert that what you expected to happen is what happened in your specifically arranged scenario. So we're going to use a context, and it'll be a new application DB context, and we're going to pass it our options. So this will be using our in-memory database, and we're going to go ahead and add a forum. So we'll say forums.add new forum, and we just need to set its ID to something. It doesn't matter what. In fact, it should just be an arbitrary number here. And so now our in-memory database has a forum that we can add posts to. And I'm going to bring in a using here so that we can get rid of some of this namespace. Now this first post, we will assign its forum here, and we can use the context forums.find the forum with ID 19, which is the one we just created. So we'll set that. We'll set the ID of the post to some arbitrary number, and the title of the first post will, let's say, first post. The content, because our search functionality is based on both the title and the content of a post, we need to provide both in our sort of mock objects here. So the content of the first one will be coffee. Okay, now we're going to go ahead and add 2 more posts. So our second post, we give some ID, and I'm just going to give it like a negative number this time. The same forum. The title of the second post will be coffee, and the content will be just some content here. Okay, so our third post will have a title of tea and a content of coffee. Okay, so we have 3 posts. Each have coffee in either their content or their title, and all of them are assigned to the forum with ID 19 here. If we're going to persist this, we need to save changes. And now we're going to act. We have a little bit of arranging to do nonetheless, but we're going to do it inside of a new context. So this was our first context, and we'll create a new one to actually search against. It's going to contain the same information that's in our in-memory database. Just have a new connection to it, if you will. And so what we can do is we can new up a post service here. Oops, post service. We can go ahead and bring in our service layer. And we're going to pass it this context, which is configured as our in-memory database now. And so let's say we have a result, which is our post service .get filtered posts. And now we have 2 overloads to use here. We're just going to use a simple search query, and we're going to pass the search query coffee. And so let's call a post count that gets returned from our result should be result.count. And for this, we just need to bring in link. And I suppose we could also just enumerate it and then call count if you like as well. But either way should return the result, which would be the number of posts from this particular search query. And so now we're going to do our assertion. So this will be our act, more or less. And so we're going to assert using NUnit syntax here. So we can say assert, and then we have a number of different methods. And so we'll say our equal 3 and then post count. And that's because coffee occurs either in the title or the content of all 3 of these posts. So it's a pretty simple test. Let's go ahead and see if we can run it. So what we'll do is in Visual Studio click on Test, and then Windows, and then Test Explorer here. And it tells us that we can build our solution to discover available tests. So let's go ahead and build our test project. And so you should see that we have one not run test here. So let's go ahead and right click and run the selected test. And so you can see that our test passed. So it's never good just to have a passing test only. So let's go ahead and assert that our results are equal to 4, which first of all can't be possible. And we'll also assert equal to 0, which can't be possible. And we'll assert equal to 1, which also shouldn't be possible. So let's go ahead and run this. And so now we'll see that our test failed. And you can see in the result output here that we expected 4 but was 3. And so let's see what happens if we just run the 0. We can go ahead and run this. And so likewise you'll see expected 0 but was 3. And so you would see the same if you ran 1 here as well. So that does seem to be working pretty well. But you can imagine that this is a relatively simple test. First of all, we are testing with an identical string here, strings with the same value, I should say. And so if a user searches for lowercase c coffee, we should also expect to see 3 results returned. So let's go ahead and run this test. So here you can see that we expected 3, but we returned 0. So what this search is kind of telling us is that we are searching on the literal string, including capitalization. And so what we can actually do is immediately improve our post service here. If we take a look here into our search query, we can modify it a little bit so that basically it will find results regardless of the casing. Say like var normalized is equal to search query dot to lower. And so now regardless of how the user typed in the search, all of the letters in the string are actually going to be lowercase. And then what we can do is say post.title to lower dot contain search query, and likewise with the content. Okay, cool. So in this case, we're still going to return, the results as the users have posted them, but our search will no longer be worried about casing whatsoever because we're going to simply call to lower on all of our searches. So in our test, if we simply run the same test again with lowercase coffee, we should see a pass. And indeed we do. So this is one of the nice things about tests. You can really try to isolate the functional components of your application, pass them the simplest possible scenario that you might encounter, and test their behavior. And when you find unexpected behavior, you can of course address it. But I think good tests will reveal what you don't realize you don't know about your application. So it's not just about finding bugs, it's about finding sort of subtle bugs like this, where you have certain expectations that you take for granted in the functionality of your software. So you would go about testing your services and each of the methods in your services in this way. One very helpful thing to note here is that NUnit provides us with a very simple way to parameterize our tests into a number of different test cases. So what I can say here is I can say test case, and in fact with test case I can get rid of the test attribute, and then test case just takes a series of objects as its argument. Let's say like coffee and then 3. And so the way this is going to work is that we're going to say when I search for coffee, lowercase, I should get 3 results back. When I search for tea, let's go ahead and just write some kind of strange permutation of the word tea, I should get 1 post back. We might have a test case here where we say water and we don't get any results back. And then the way that we have this run is that we basically pass those as variables into our actual method. So we'll come down here to our result and we'll get filtered posts based on our query. And then we'll assert our equal, our expected value versus the post count. And then if we go ahead and build our test project again, you'll see over on the left we now have actually 3 tests. All because of the fact that we created 3 different test cases for the same type of test here. So we can just click run all. And so here we can see that we had 2 tests fail. Our test with the query coffee passed, but the other 2 tests actually failed. And so if we take a look at why it failed, we can see that an item with the same key has already been added, key 19, and this is the same error on both of the failed tests. So what's happening here is that our tests are actually reusing the same in-memory database when they're running, and so what's happening is we already have a search database with a forum of ID 19, and it doesn't even make it past this insert. And so what we can do here is specify the database name as a GUID, and so this way we'll get a unique name each time one of our test cases is run. Okay, so I'm just going to generate a new GUID in place here and have that serve as our database name. And that way we can run 3 test cases and we'll have 3 completely separate databases into which we can create a new forum with ID of 19 and then our 3 posts. So let's go ahead and give this another shot. Okay, and this time we got 2 tests passed, coffee and water, but tea failed. And here everything ran fine except that we saw that we expected 1 but was 0. And so let's take a look. We have T here, which should get called to lower, and our forum and our post title here should also contain T, and we should call it to lower on that. And so let's go take a look back at our post service and double check that it's implemented like we would expect it to be. And so we had a subtle bug here, actually maybe not so subtle. You can see that we created this normalized variable and then did not implement it here. So this should actually fix our expected behavior. And so we'll go ahead and run the test again. And we can see that all the tests passed. And so I intentionally set this up in such a way that you could make small mistakes like this when attempting to fix bugs or when writing features for the first time, and then show you how your test can kind of reveal some small bugs that might be hard to catch at first glance. Now in this case, this is maybe a little unrealistic since we went in here to actually explicitly change this method to pass in a normalized variable and then we didn't use it. Well, maybe people normally wouldn't miss that, but In any case, just to illustrate that your tests will pass if things are working as expected, if you construct them in such a way that they exhibit the behavior that you would expect. And of course, there's a lot of different test cases you could test here. You could test longer search queries, and now in that case, you might realize that you want to do something more than the simplistic contains here. Maybe develop some algorithm that diffs a set of strings, that might diff your search query string against the title or the content string, and then see if any of the words that come back from either string appear in your query and in the title or the content. You might even get more elaborate and do some type of custom tokenization or lemmatizing or some other operations on strings here to do more fine-grained tuning to your search service and ultimately what might become your search algorithm. In any case, as you develop features, I hope that you heavily consider testing them and allowing your tests to kind of not only reveal the subtleties of your functions, but also drive you towards writing improved functions and improving the functionality of your application. The other nice thing about tests is that if you're in a project where you're working on it with multiple people, then you can be sure that, as others are making commits into the code base, that your test suite continues to run with all passing tests, which should give you some increased level of confidence that your code will actually function as you have designed it to. I'd also like to tell you about two more types of test attributes that NUnit provides for us, or actually four more. We have some setup and teardown attributes. So we, for instance, have one called one-time setup. We also have one called one-time teardown. And if you create a method with one-time setup in your test fixture, then this is going to get called once per test fixture setup. So if we had a dozen tests in this test class, then one-time setup would get called before any of those ran, and one-time teardown would get called at the end. This is really useful for things like automated browser testing, when you may want to, say, open a browser at the beginning of a set of tests and then run through your tests and then close the browser at the end of the test. But it could also be useful in other types of unit testing scenarios as well. Then the other two methods that we have that can be used for some action before or after tests are simply setup and teardown. And so as the name suggests, one-time setup and one-time teardown happen once, and setup and teardown will apply to each individual test. So if I had a method setup before every test, then I would use the setup attribute for this type of method. And so again, if you were doing automation browser testing is another thing that comes to mind here. Let's say that you ran all of your tests as a particular test user, then you might have some method like login as test user at the beginning of setup, and I don't know, in teardown you might have after every test. Here you might have something like clean up test artifacts or something that you would want to do at the end of every individual test. So just some ideas, and to be aware that they're out there. Certainly the test case attribute is one of the most useful attributes that we have in the NUnit framework.